Okay, welcome everyone. So this is the first class of the this course. So sorry for the delay. But so actually the computer settings are changing during the vacation. So I need to set up some computer settings for this June and my tablet. Okay. Sorry for the delay. Okay, so welcome to computer architecture course. Okay. So this is the mandatory course of in the computer engineering department, right? So it means that this course is a kind of important course in computer engineering, right? So in this time, so I will briefly introduce about this course, right? Okay. So this is the object of this course. So you can see the this slide, PowerPoint slide. So what is the object of this course? The object is exploring computer system architecture at an abstract level. Okay, so you can find the abstract here. And also you can find the terminology, computer system architecture. So then, what is the meaning of architecture actually? So, the architecture is the kind of sorry, construction terminology, right? So we can frequently say that. So this what is the architecture of this building? And what is the architecture? So it means ujo in Korean. So we frequently say that the architecture of this whole building is kind of good, the fancy. Then what is the architecture? So if we say architecture in building or construction, so that means this is kind of planning or some blueprint. Okay, so before starting constructing a building, we firstly make a plan. Well, we first make a blueprint of the target building. Okay, so that is called the kind of building architecture, right? Then what is the computer architecture? So actually, the computer system. So we are studying about the computers, right? So we want to study about the computer software and computer hardware. So it means, the computer systems are composed of software parts and hardware parts, right? And then actually, in order to understand how computer works, then we need to understand how software works, and also we need to understand how computer hardware works, right? So in this course, we will learn how computer systems works. Actually, we will focus on the hardware and hardware software interface. Okay, so you actually normal users are facing software part only, right? So if we use a computer system, then actually we use computer software, right? we run computer software such as some applications like the office applications, internet browser, game application, blah blah blah. So actually we use computer software, right? But these computer software applications run on computer hardware. Okay, so in order to understand how computers work, so firstly we need to understand the computer hardware architecture, right? So actually the object of this course is to explore computer system architecture, but abstract level. So what is abstract? So in Korean, it's called 추상화, right? So actually, abstract means that we just ignore the difficult part, but and this difficult part is not required for our understanding. Okay? Just to ignore the some difficult part, and then but we just understand the what is some requirement for the target system. So actually, we will learn about the abstract in the next class, right? So it's kind of an abstract. So we will learn about a certain level of abstraction in computer systems. And then this abstraction level is architecture level. Okay, so in this course, we will learn about the computer system architecture at an abstract level. Okay, so in this course, so we will learn about the basic concepts of computer systems. Then, so firstly, we will learn about the performance. So we need to understand the performance of computer systems. Why? This is because everyone wants to use fast computers, right? Good computers. And then fast or good represents the performance of computer systems. So firstly, we will learn about the performance metrics of computer systems. In this course, each part, instruction set architecture, then the process architecture and memory hierarchy. So these three parts are critical parts in this course. Okay? It's important parts. So we will learn about the instruction set architecture, right? Like the x86 or ARM. Actually, that represent those terms like x86, ARM represent instruction set architecture of a computer system. Okay, so we will learn about this instruction set architecture. And then this is kind of review the arithmetic and number systems because the computer, we will learn about the computer hardware. And in order to understand the computer hardware, so we need to understand the arithmetic logic. Okay? And then another important part is processor architecture. So every computer system includes CPU, the central processing unit, right? So I mentioned processing unit. So it's also called a processor. So we will learn how a processor works in computer systems. Okay, so this is another important part, the in-order processor architecture, and it's also called pipelining. It's very important concept. And so we will learn about the memory hierarchy. It's also very important, okay, because our data is stored in memory systems. Okay, so actually the memory systems are very critical for the performance of computer systems. And then parallel processor architecture. So just to remember that, if you take this course, then you need to understand about the instruction set architecture and pipelining, memory hierarchy. So those are the three important parts in this course. Okay, so this is the textbook. So I also have this textbook. Okay, so the title of the textbook is the Computer Organization and Design and Risk 5 edition. So in the previous slide, I mentioned instruction set architecture, and then actually the risk 5 in this slide is a kind of instruction set architecture. So we will learn about the risk 5 instructions. Okay, so this is the textbook, and then so in this course I will also provide the Okay, so I will provide the lecture slides. So you can also, I believe you can find the lecture slides in Blackboard, right? Korea University Blackboard. And then actually in this course, I will also provide some design maps. Okay. And then so actually for these design labs, you need to use the uh, compiler. Okay. C or C++ compiler. So actually, so we will use the RISC-V ISA, the instruction set architecture simulator. And then in order to use this simulator, then we require a compiler. Actually, we use the cross compiler. Okay. And then also in this course, I will also use some code snippets. And then actually I will explain based on the C programming languages. So it is because C is the very basic programming languages, right? And then also actually this is the fundamental language for understanding computer hardware. Okay, that's why I will frequently mention C code in this course. Okay, not Python. Python is kind of different type of language. Okay? And then, so we also have some design lab, and then in this design lab, you will be required to design a processor using audio description language. So it's a kind of a programming language. And then if you took the digital logic design course, and so actually I taught about the system Verilog. So actually, so we will use a system Verilog, is audio description language for designing the processor. Okay. So and then Verilator. So Verilator is the HDL compiler. Okay. So actually, so our system Verilog design needs to be compiled into some compiled into some loop, not assembly, it's kind of some code, and then actually we need to learn this code to simulate our design. Okay. So actually these are required. And then if you are not actually, I recommend to purchase this book. Actually, this book is a very popular book in the computer architecture area. Okay. So if you are actually, I know that recently the students do not read the textbook, but I recommend to read the textbook. Okay, it's very important. Okay, so if we are not familiar with the English book, then we can also purchase the Korean book. So it's like so this book is written by Professor Seo. Okay, so it's a very good book. Also, we can also, so this is another book, like this the design and computer architecture. Okay. Okay. What they? So they are authors of this textbook. So computer organization and design. So I mentioned that this book is very popular. So it's a very famous book in computer architecture area. And then these are these people are authors of this book. Then they are very legendary people in computer architecture. Okay, so they are Hennessy and Patterson. Okay, John Hennessy and David Patterson. So so this is the old picture, and then this is the recent picture. Okay, so they received the Turing Award. So you know the Turing Award is a kind of So very similar to that. It's called the no, Nobel Prize in computer engineering or computer science. Okay? So I mentioned that they are legendary people. Actually, so they developed the risk type instruction set architecture. Also, they also developed the risk file. Okay. So if you are interested in these authors, then you can also click the ISCA 2018 Turing lecture. Okay, actually the so if people receive a Turing award, then they also uh, provides the Turing lecture. So these lectures are very famous and then very useful lectures. So if you are interested, then you can click this link, and so you can watch the Turing lecture by these authors. So welcome to computer architecture. Okay, so the prerequisite of this course. So I mentioned we will use system Verilog audio description languages. Then actually I covered this system Verilog languages in this the logic design course the last semester. So actually this course I will not teach about the system Verilog syntaxes. Okay, so if you are not familiar with system Verilog, then you need to study by yourself. Okay, so I can provide some video link for some of my lectures, but you need to study it by yourself if you are not familiar with the system Verilog. Okay. Okay, we will use system Verilog and Verilator. It's kind of a system Verilog compiler. And then, as I mentioned, so you need to have basic knowledge on computer programming languages, especially C, not Python. So actually, as I mentioned, Python and C are different types of programming languages. Why? You know, C is a compiler-based programming language, and Python is an interpreter-based language. Actually, it's different. Okay. So actually, in this course, so we will learn about the process of compilation. So it is because we will learn about the instructions, right? So actually, our code needs to be compiled into or translated into instructions. Okay, so I mentioned compiled, or translated. So actually, C is the compiler-based language. So that's why. So I will mention C code frequently in this course. Okay, not Python. So if you have some knowledge on the programming languages such as C, then it will be useful. Okay, and then also this is also important. So basic knowledge on how to use command line interface of Linux operating system. So I know that the students are familiar with GUI, the graphical user interface, like the Windows or our Android phone or smartphones, right? Okay, smartphone. So actually, so we can run applications by clicking icons, right? It's called the graphical user interface. But so we are studying computer science and the computer engineering, right? So it means you need to be familiar with CLI, the command line interface, and then actually Linux operating system. So this is because, so as I mentioned, so in this course, we have design labs, several design labs, and then we will use compilers or the validator. Validator is also kind of a compiler. And then these compilers run on Linux operating system. Okay. So actually, in order to run these compilers, so you need to use the Linux commands, right? Like cd or ls. It's a kind of a command line Linux operating system commands. Okay, so please be familiar with the command line interface of Linux operating system. So I will not teach about these commands, right? So this is the computer architecture course, not the Linux operating system course, right? So, and then actually you can run Linux operating system using the virtual machine, such as the virtual box or VMware. Okay, so these are required. And about me, so my name is Gu Banjae, and then this is my office, and then this office hour. So you can visit. You can stop by my office by one appointment. Then, if you have any questions, then you can email me. But if you have questions about the labs, assignments, or exams, and you need to use Piazza. Okay, so this is my email, and then my research area is computer architecture, right? Generally, and then I'm working on these topics. And then, so this is the TA information. So we have 2 TAs. So you can find the TA email address. So actually, even though I provide the TA information here, but TA's roles are grading homework and grading homework or lab assignments and exam. So TAs will answer the questions on Piazza. So this is important. Do not email TAs regarding homework and lab questions. Okay. You need to post your questions on Piazza. Okay. Do not email TAs about your homework questions or exam questions. Okay. So also regarding the attendance, you can email me. Okay. So as I mentioned, so we will use the Blackboard, Korea University Blackboard, and then actually I will post the some lecture slides, and then I will post homework assignments and then lab assignments on Piazza. Not Piazza. It's a Blackboard. Okay, Korea University Blackboard. So you can also download the lecture slides. And then for questions, you need to use the Piazza. So this is the address of Piazza, and you can join as a student, obviously, right? So join as a student, and then for sign up, you require the access code. Access code is Claremont. Okay, it's the kind of it's the name of a city in US, in the United States. So anyone can post questions and answers. Okay, so as I mentioned, you need to post your questions regarding homework assignments, lab assignments, and exams on Piazza. Okay, do not email TAs. Okay. Also, you can visit this TA's office. The TA's office is the this building 401C. Okay, so you can get help for some your assignments like lab assignment. So it is because so I know some of you are not familiar with the Linux operating system or compilers. So if you have difficulties in using some compilers or simulators, then you can get help from TAs. You can visit the TA's office. So that's why I provide the TA's email address. Okay. But for the general question like the homework and lab assignment, then you need to use the Piazza. Okay. Okay, this is the Piazza. So you can find the questions here. So as you can see, so this is the question from students, and then I also answer the questions. Okay. Then also I post some materials on Piazza, and then also you can find the link to Piazza on Blackboard. So if you see the Blackboard, so you can find the left panel here, and then you can find the resources, Piazza and then Piazza. If you click on this link, then you can go to Piazza. Okay. And attendance check. Sometimes, so attendance check is important. So in this course, so please use self-attendance check system. Okay, self-attendance check on Blackboard. So I will not call your names during the classes. So I think it's a kind of waste of time, right? So you are adults, right? So so actually you need to manage your life, so your time by yourself, right? You are adults, right? I will not call your names. I will not check attendance during the classes or lectures. So we are very busy, right? So please use self-attendance check. And then you can find the self-attendance check on the Blackboard. Okay. That's also important. You will get F in this course if you miss more than 1/3 of these classes. Okay, so it's a kind of a strict rule by government, not by university. So it's a rule by government, Korean government. Okay. So as I mentioned, we will not check your attendance manually, but sometimes we will take pop quizzes accidentally. Okay. So actually in the past semesters, I found that so some students check their attendance on the Blackboard, but they did not take the pop quiz. Okay, means so actually they checked their attendance. It's a kind of fake, right? So if your attendance check is mismatched with the pop quiz submission, then you will get penalty. Okay, so please behave honestly. Okay. Absence. So if you miss classes due to serious illnesses or flu or COVID-19, still, so recently the COVID-19 is spreading. And then also some kind of public events such as the reserve force training. Okay, then you can request the waive of attendance using Korea University portal. Okay. So please submit proofs. So, so as you know, so I'm recording, this, class. So my lecture using Zoom, okay? So, if you need to be absent from classes because of flu or COVID-19, then you can request Zoom link, okay? And if also you can take the right, the video lecture via Zoom, okay? Mhm. And logistics, so, you know, so we will have classes every Tuesday and Thursday, 10:30 to 11:45, and then so classroom is will be one-on-one. And this is the grading policy of this course. So we can find some fractions of grading. Okay? It can be changed. And then exam. So we will take the on-site exams like midterm exam and final exam, 2 exams, and then it's a closed book, and then no electric devices are allowed. Okay? Which may result in F in this course. Also, you can answer in Korean or English. Okay, so this is the English course, right? And then, but many of you are native Korean. So actually, in during the exam, you can answer in Korean. Okay, but the questions will be written in English, right? So this is the English course, right? And assignments. So we will have around 5 homework assignments. Okay. So I will provide the homework assignments after every chapter. So actually, so if you see the here, so some topics of this course, the performance, so instructions and architecture. So these are chapters of this course. So I provide the, it's my plan. So I plan to provide 5 homework assignment and 6 design labs. Okay. So 2 labs are regarding ISA, the RISC-V ISA simulation, okay, instructions and architecture, and then 4 labs we will use the system Verilog and Verilator. Okay. So we will have 5 homework assignments and 6 lab assignments in this course. And then this is the late submission rule. So we will apply 20% of a penalty for every 24 hours delay. Okay. So it means, so if the deadline is the 11:59 p.m. and then if you cannot meet, if you cannot meet the deadline, so which means that if your submission is delayed by 10 minutes, then you will get 20% of penalty. It means that your score will be 80% of your final score. For the submission, that's for the homework submission and lab submission. So you will get 80% of your score. Then we will not accept the submissions later than 48 hours. Okay. So this is the latest submission rule. And then this is the kind of plan of this course. Okay. Okay. So the exam. So we will take the exam on October 29 during the regular class time. So I know this actually this is out of the exam period, but I think that this date is reasonable. It is because we need to miss 2 classes because of Chuseok, the Korean holiday, and then National Foundation Day. So, but even though we miss two classes, but the exam period is the same. So I think we need to take the exam on October 29th during the class. Okay. And then final exam is for December 19th. Okay, during the regular class time. Okay, this is the end of syllabus. Any questions? Okay. The class. Yes. No, actually no. No. So actually we will have three classes in this course. Okay. And then so actually there will be no makeup classes for this canceled classes. Okay, so so you know this is even though this is the first day of this course, so I will introduce about this computer architecture course. Okay, so as I mentioned, so what is computer architecture? So I mentioned that this is computer architecture represents the study on computer systems, but we will focus on hardware and hardware software interface. Okay. So interface means that the software needs to be executed by hardware. So we will learn how software is executed by hardware. Okay. So as you can see, this is the kind of computers, right? Very old computers. Right? So this actually, this is the PDF. So this is the first personal computer by IBM. So this computer. And then you can also find the early Apple computers. Okay, and then also the shape of computer systems can be weird. So you know, so this is the modern computers by Apple. Okay. Also, computer systems are pervasive. So it means that actually we use computers every time. And then everyone uses computers every time. Okay? Why? We use our smartphones, we use smartwatches, and sometimes we use smart speakers, right? And then actually those devices are computers. Right? Why? So we already know that, oh, these are computers, right? So computers have keyboards, mice, monitors, and then main device. Like this is the main computer device, right? So we think that, oh, these are computers, right? But also these devices, actually these electric devices are also computers, right? Why? So we will learn why, but answer is that these devices include processors that will execute instructions, right? So I mentioned instruction set architecture. So these devices will execute instructions which are compiled from high-level languages. Okay, That's why these devices are also computers. Actually, same. The same is computers, and then these computers, the fundamental, the working working parts is the same. Okay, so and then recently, so we can also call these devices are computers. It's a kind of domain-specific computer systems. So what are those? So this is the Google TPU, the tensor processing unit, and then using Google TPU, we can run AI applications, right? And then this is the Intel FPGA card. It's a kind of also accelerator. So using the FPGA, we can also run specific application. It's called domain-specific applications. What is this? GPU, right? So it's NVIDIA workstation GPU, so Titan. And then, so actually we can use GPUs for game applications, the image processing or video processing applications. And then recently, we use GPUs for AI applications, right? So actually we can call these devices are also computers. So it's a little bit different because when we mention a computer system, a computer system includes CPU, the central processing unit. But these devices are not CPU. So actually, the called the GPU, the TPU, it's a different kind of processing unit. But recently, we call these devices are also computers, so kind of part of computer systems. So it means computer hardware is changing. Okay. Traditionally, this is the structure of or shape of computer system, but recently the computers are changing. Okay, so that's why the computer architecture is very important. Also, what is this? So these are photos of data centers. Okay? So we may think that, oh, those are just the data centers. Okay, actually, it's a cloud infrastructure. And then also, the computer, when we mention computer systems, also the computer architecture or computer systems also includes this gigantic data center architecture. Why? We can use data center resources like a personal computer, right? So we can use our smartphone, but our smartphone is connected to cloud. The cloud has its data centers. So actually we can use the resources in cloud infrastructure like our personal computers. That's why, so this gigantic data center architecture is also, it's a kind of computer systems. Okay, so computer architecture, in the computer architecture, we will learn about the computer systems. So you can find the washing machine, the supercomputer, laptop, smartphone, and then Raspberry Pi, and then what's this smart TV, smart speakers. So this can find that actually these, we can say that, oh, these are computers. Because these devices include the processor, the central processing unit, okay? And then central processing unit execute instructions. Okay. So this is the kind of computer revolution, which means that so actually, and then traditionally we just run general purpose applications using our computer systems, but now we run the various kinds of domain-specific applications using computers. So computers have some different form factors, such as the desktop, laptops, supercomputers, or smartphones, the mobile computers. Okay, so computers are pervasive. So these are kind of computers like personal computers, server computers, supercomputers, and the embedded computers. So actually, so those are different types of computers. So we can say that these are so desktop computers and then laptop computers are kind of personal computers. So what are the features of these personal computers? So how can we use our personal computers? Usually one or two users use personal computers, and then we can run any application, the general purpose. So when we design a personal computer, then we can design this computer system for personal use. So one or two users will use, and general purpose. We can run any application. So this is the supercomputers. Then what is the purpose of supercomputers? So using supercomputers, we run scientific applications or parallel applications, right? So supercomputers are designed for these applications, high performance, parallel processing. Okay. And then these are mobile computers, or it's also called embedded systems. So, for example, smartphone is the kind of mobile computers. So what is the feature? What are the features of mobile computers? So we can run any application. It's a kind of general purpose. But for the mobile computers, battery performance is critical, right? Because the mobile computers are not connected to power sources. We need to use the mobile computers use battery. Okay, so it needs to be energy efficient. Okay, well, we need to consume less power. We can design the mobile computer systems like this. Performance can be low, but it should be energy efficient. Okay. Okay, we can design some different types of computers by various purposes. Okay. Then questions. So I mentioned that so actually everyone wants to use their own computers, right? And then if you are interested in computer systems, well, so their own computer systems, then you can usually compare the clock frequency of CPU, right? If the clock frequency of CPU is higher, then we can say that, oh, this CPU is better than those that CPU, right? Is it because if the clock frequency is higher, then we can say that, oh, this is faster. Then, so there are different, these are different type of CPU, right? So this is the very old. It have Q for working with the 1.3 gigahertz. Then this is the Raspberry Pi. Raspberry Pi has ARM processor working with 1.2 gigahertz, which is better. This processor, because this processor is working with higher clock frequency, right? Actually, we will learn about this performance metric, but actually we don't know why. The performance of a computer system is determined by many factors. Not clock frequency is critical, but it is determined by many different factors. So even though this Pentium has higher clock frequency, so we don't know about the performance of this processing. Also, the Intel Pentium use x86 instructions, and then Raspberry Pi, this ARM processor, uses ARM ISA instruction sets. So actually, we don't know which processor is better. How about this? So it's the same Intel processor. It's an Intel Xeon, and this is the Intel i7. And which processor is better? Which processor is more expensive? Xeon or i7. So actually i7 is actually the Intel changed the processor name recently. i7 is so i7 is so this is the processor for personal use, and then Xeon processor is used for server computer systems. Server, high performance server. Which is better? Actually, we can say, so actually, Xeon processor is more expensive, okay? Because this CPU is used for server computer systems, but which processor is better? So which means that which processor is faster? It depends on workload or applications. Why? So I mentioned that actually there are different classes, different types of computers, such as personal computers, server computers, supercomputers, and I mentioned that the design purpose for these different types of computers are also different. I mentioned the Intel Xeon is used for server computers. Then Intel i7 is used for personal use, so desktop or laptop computers. So actually, the Intel Xeon includes more cores. Core means kind of CPU, okay? But Intel i7 includes less number, less cores, a smaller number of cores. But the performance, the clock frequency of Intel i7 can be higher. Okay, so I mentioned it depends on workload. It means Intel Xeon is good for parallel workflows. Okay, so server workflows because the many users use server concurrently. That means that a server computer needs to run any application concurrently. So Xeon is designed for servers. But i7 is designed for personal use. So it means when we just compare the performance of a CPUs, then we need to also think about some use cases, purposes. We can also apply different performance metrics based on the purpose of CPU design or process the computer design. So another comparison is the Xeon and NVIDIA Tesla. The NVIDIA Tesla is the GPU, so it's a workstation GPU. So it means that we can use actually Tesla for the parallel applications like AI applications. So why do I show these different the GPUs and GPUs? So it is because I mentioned that Intel Xeon includes many cores, but the number of cores in Intel Xeon is around the 20s what 30. Okay. So actually the Intel Xeon includes the tens of cores. But how about the GPU? So NVIDIA mentioned that NVIDIA advertised that the GPU includes thousands of cores, hundreds of cores, recently thousands of cores. So if we just compare the number of cores in a chip, then NVIDIA Tesla is better than Intel Xeon. So it can be true for the parallel applications, but because the processor architectures are different for the CPU design and GPU design, so we cannot directly compare the performance of these CPU and GPUs. So it means processor architecture also influences the performance of computer systems. So if you take this course, then you can also learn why the performance is determined by many factors. Okay. So actually, the performance can be determined by these factors. Okay, algorithm and programming languages like the Python or C, and then processor and memory system. So it's a kind of hardware part, and then I/O systems, including operating systems. So computer systems are very complex systems, right? And then, so which means the performance of our computer system is determined by many factors. So algorithm is a kind of software part, and then programming language, compiler, architecture like Python, instruction set architecture. So programming language, how about the Python and C? Which is faster? Python or C? C. C is much faster, actually. The programming language also influences the performance, and then compiler. Compiler is also critical. Okay. Then instructions. Then also hardware architecture like the processor and memory systems also influence the performance of a computer system. And then I/O, input and output devices such as network and storage like SSD or hard disk drive. And so these I/O devices are controlled by operating systems. Operating system also influences the performance. Okay, so why do you need to learn? Why do you take this course? Because it is a mandatory course, right? So you may think that this course is a little bit tricky because it's actually, if you are just familiar with the software part, then this course may be tricky because in this course we will learn about some IPRO level of computer systems. So actually we just interface with software. So that's why software, we can think that our software is easier because we just interface with software part. But the hardware part is under the software layer. So that's why you may think that, oh, this is a little bit difficult to understand. It's a little bit tricky. But, you know, so I think many of you, not some of you, not many of you. So this is the mandatory course in the computer engineering. But this computer architecture is very critical. Okay, critical for understanding the entire computer systems. So why do we need to learn? We need to learn about we need to understand the computer systems. And then, oops. Actually, if you study on computer architecture and Institute for, actually computer architecture is required for building better computer systems like higher performance and then lower energy cost. So this is kind of a hardware part. Only for hardware engineers? No. Why? The knowledge on computer architecture is required for software engineers also. Why? As I mentioned, the software is running on computer hardware, which means if you can understand how computer hardware works, then you can build better software. Obviously, because the software is running on hardware. So it's required for better software design. Also, recently, as I mentioned, the modern applications use domain-specific processors such as GPU or PPU. So which means these applications like domain-specific software, domain-specific applications exploit some native features of these specific processors. Okay, so if you understand the architecture of processor better, then you can also understand the domain-specific software. Okay. Then this is also very important, hardware software co-design. So actually, if you can understand the hardware software architecture, then you can also optimize the entire level of computer systems. Okay? If we just optimize the software, it's kind of a local optimization. Okay? So sometimes hardware software co-design is required for some better optimization. Okay? It means It's important. Okay. So, I hope everyone uh, focus on this course, and then also everyone can get some uh, good analysis or better analysis on the computer systems by through this course, by taking this course. Okay, okay. So this is the kind of introduction of this course. Then I will stop here, and then as I mentioned, so in the next class we will learn about some abstraction level of computer systems. Any questions? Okay. Good question. So actually, we use the very low in the time level in the mid after the middle of this course. So actually, so the first lab, actually, but I mentioned I know that some of you are you some of you do not take the logic design, so some of you are not familiar with the system value. So actually, in the first lab, so actually, even though we just use the Verilog after this lab 4, but I also provide the first lab, we will request you to install Verilog tools and some virtual machines. Okay, so actually I designed the first lab like this. But so we will use the Verilog from this lab 4. Okay. Okay, so, thank you for attention. Then see you in the next class. 감사합니다.